Advanced LAN Configuration Part 1. Catalyst 3550 VLANs, VTP, and Ether channel. This nugget is going to get our feet wet with the world of switching using the Catalyst 3550. It's my favorite piece of Cisco equipment. You'll see why as we go through this. I plan on starting off by going through a conceptual review of switching. We're not going to get down to that level, what a switch is and so on. I'm going to make a lot of assumptions that you have the foundation switching down, which you should by this point in time. But I'm going to cover some of the key concepts that we're going to use in this nugget. Then we're going to focus in on the Catalyst 3550. It is the switch of choice on the CCIE lab exam, and you'll have to know how to make this thing stand up and dance. So I'm first off going to go through the switch management, some of Cisco's best practices when you first get that switch set up. We'll get into the configuring VTP and VLANs, and then we'll look at trunking using Ether channel 802.1q, ISL, some of these different trunking protocols, and combining them with all of the pieces that we put together so far, setting up that switch from the ground up. So if you're ready, I'm ready. Let's get going. Now, before we get going, I want to take just one slide as a desperate attempt to get you as excited as I am about this Catalyst 35 series switch. It's awesome. I title it, Why the Catalyst 3550 Will Rock Your World. Number one reason, and this is the one that stands heads above all the rest of them, is the fact that it may look like a switch, but that's about it. This is one of the first stackable switches out there that can be a router as well. One simple command. I go under interface configuration mode for any one of these ports. This is a 24 port model. I type in no switch port, and instantly that port becomes a router, capable of having an IP address, capable of participating with routing protocols. It's awesome. Let me give you an idea, just maybe an example that might hit close to home for some of you. Take your DSL or your cable modem connection that you have at your house. You could go ahead and connect two cables to this. You might connect your DSL modem or your cable modem to this port, run the Ethernet line in, and connect this port out to another switch. Or even better, use all these other ports on this switch for your internal hosts. Type no switch port under here, and you can then route between your internal network and the DSL or cable modem, applying access lists, firewall features, all from one stackable switch. Whoa, never before was that possible. We used to have to buy a router and a switch to combine those two functionalities. So that's the biggest one in my book, is this number one key. And we'll see more of that as we cover the features. Second reason here, uplink fast, backbone fast, and rapid spanning tree protocol all set up and ready to go out of the box. We're used to pulling a switch out of the box, plugging a cable in for a computer or an Ethernet connection, and waiting 30 to 50 seconds for spanning tree to finally say, okay, it's okay, it won't cause a loop in my network. No more. Try between 1 and 2 seconds before that goes active with rapid spanning tree protocol. Uplink fast and backbone fast is used when we're trunking to other switches. They deal with making sure that there's no loops in a very fast configuration. Those are all on by default. We used to have to upgrade and enable these features on other switches. I had to outline it. Huge bandwidth optimization using layer 2 and layer 3 Ether channel. Truth be told, you can get up to 16 gigabits per second trunking between these switches. That's combining a bunch of gig ports or 100 megabit per second ports all together into one Ether channel trunk, and it supports it at layer 2 and layer 3. If you haven't seen a layer 3 Ether channel before, stay tuned for the rest of this nugget because we're going to get into that. Finally, the advanced qualities of service features. As an IP telephony guy, this is near and dear to my heart. I want to make sure that my voice gets across the network without getting squashed by the data traffic. This comes with all the quality of service features that I need to make that happen, and I can enable them all at layer 2, layer 3. This is a router and a switch. Don't forget, it's not just a switch anymore. It looks like one, but that's about it. There are currently 4 models of the 3550 that are out there, and this doesn't cover all the offshoots of these models. For example, you might see something like the 3550-24-PWR for a switch that supports inline power for IP phones. These are just the major umbrellas of models. First off, as I mentioned, 3550-24 and 48, as we see on the screen right here, support 24 ports and 48 ports. Oh, look at that. That's as dense as you can pack a stackable switch. You then come down to the 3550 12T and 12G, and if you look, you can see the difference. 12T has 10 base, 100 base, and 1000 gigabit per second ports that it can use, along with 2 GBICs that allow you to get up to gigabit per second on fiber. This one flips the whole scheme. We have 10 GBICs where you can put in your fiber modules, and then 2 of the Cat 5 or Cat 6 10, 100, 1000 base T ports that you can use. And these are the hardware models, but there's also something that you need to be very aware of when you're ordering one of these switches, if you order one of these switches. There's 2 major software images. There's SMI and EMI. These are a pretty big difference on this switch. Now, these switches, you don't have to have a specific hardware platform to support either image. Here's the difference. SMI supports the switch in basic routing functionality. You'll have everything that the switch is able to do, most quality of service, most router functionality, like RIP as a routing protocol, things like that. This one, I'm telling you guys, you got to get it. It's the enhanced image for it, and what it does is it adds all of the features. You can throw BGP on this switch if you wanted to. You could have OSPF. All the quality of service features are at your disposal. This is pretty much the entire kitchen sink being thrown inside of the switch. You can jump on Cisco's website and just search for SMI versus EMI to see all the features that are a major difference. But the main one that I run into is the quality of service and the routing protocols. EMI is the one I use because it supports all the major routing protocols that are out there. When you get to your CCIE lab exam, you better be sure they're going to be using the EMI image so that they can have you doing anything on that switch that it's capable of. At this point in your Cisco journey, you should be familiar with what VLANs are all about, and I don't want to spend our time going over what VLANs are, but instead I want to take a look at the use of VLANs and now what's called integrated switch routing that we're seeing with the 3550s and a lot of the chassis-based switches. First off, we see the legacy VLAN routing. This is how you and I probably first learned how to get between VLANs on a switch. For example, we've got a switch here. It's got VLAN 1 with one computer down here, VLAN 2 with one computer down here. Now, VLAN being synonymous with subnet requires that we have some sort of routing capability to get between these two. This guy cannot communicate with this guy without having some sort of routing in place. And the way we used to do it, the legacy VLANs used to use the technical term router on a stick. You can still go to Cisco's website and search for router on a stick and find exactly this. We create a trunk going to the router, sending all VLAN traffic. And if this computer, we'll say he's 172.16.1.5, wants to go to this one, which may be 172.16.1, or we'll do .2.5, which is maybe another subnet, he would have to go out onto the trunk, into the sub-interface of a router, then out another sub-interface, and go back to the switch, having our encapsulation change so that we can access the other VLAN. This was fine and dandy, but the problem became this is a major bottleneck. If we have this computer at 100 meg per second, and this one at 100 meg per second, and our trunk at 100 meg per second, well, if you get any more than 2 computers sending to each other at a time, we have a major bottleneck that's taking place on this little router on a stick. So what's become in the modern VLAN routing is they've integrated routing functionality inside of the switch, and this is how we're going to do it on our 3550s. We still have our VLAN 1 and VLAN 2 with our computers, but now instead of having an outside router, look at this. We create VLAN interfaces What are they? Well, they're logical virtual interfaces inside of our switch that we're going to point to do our routing. So let's say that in this example, 172.16.1.5 is going to point to a default gateway of this. VLAN 1, 172.16.1.1. We're going to go into interface configuration mode for VLAN 1 and assign it a virtual IP address. Same thing here. We'll put this one on 172.16.2.5. Default gateway, you guessed it, is going to point right here. Now we don't have that trunk bottleneck because we're using the backplane of the switch, which can support gigabits per second. And you better believe it's routing like a snap when we're going into that switch and just hitting the backplane and the logic fiber that is tying that switch together. So that is how we're going to do modern VLAN routing on our 3550s through the use of VLAN interfaces, and these are also going to come into play when we see layer 3 ether channels. Since we were talking about VLANs, I want to hit one more concept review with you, and then we'll spend the rest of this nugget all about configuring that 3550, and we'll spend it in the live interface. I want to talk about the VLAN trunking protocol, which is really not a protocol at all, but a way of replicating our VLAN data between our switches. And just to refresh everybody, you might have two switches, two 3550s, trunked together with one or more lines. You create a VLAN up here. We'll say VLAN 1, 2, 3, and 4 are created. And instead of having to go to every switch in our network, it immediately replicates those down to all the other switches. This is a big time-saving measure, but can also be a huge, huge security flaw. And the reason why I say that is because somebody could bring in a rogue switch either maliciously or just not even thinking. You buy a switch off of eBay or something like that, and you end up bringing it in with the configuration already there. Well, VLANs and VTP works on a very, very simple increment that it uses for its revisions. Essentially, this is how it works. When I make any change to a VLAN, I change the name, I delete one, I create one, I make any change to a VLAN, a revision number will increment on my switch. Starts at 1, goes to 2, goes to 3, goes to 4. So essentially, the number of changes that you've made will be reflected in that revision number. When you have multiple switches on the network, the highest revision wins. So you bring in that eBay switch that you just bought to test and play around with, accidentally plug it into your network. It's been in use on a network for years. It's at revision 5002 while yours are all at revision 905. What happens? Well, your VLAN database gets blown away by this switch, and it replaces it with its VLAN database, nuking your current network. A lot of companies have banned the VLAN trunking protocol because of this security flaw, but I'm going to show you how to configure it securely so people can't just walk in and do this. Now, there's 3 modes that a switch can be in for the VLAN trunking protocol: server, client, and transparent. Now, the reason it's so dangerous is every switch is a server when you first pull it out of a box. And a server can create, delete, modify, do anything to the VLANs and replicate those to other servers or other switches in the network. If they're all servers, it's just going to go by the revision number. The biggest one wins. Now, the client is the safe mode. A lot of companies will pick one server in their network, they'll designate the server, and all the rest of their switches will be clients, because a client can't change anything. It can't create, it can't delete. All it does is it receives the updates from the server. So this gives you a central point of control and a central point of security for those VLANs. Transparent switches are like the Harley riders. They're the rebels of the entire network. They can receive updates, they can even pass them through, but they don't listen to them at all. When they receive a VLAN update, they're just going to say, you know what, I am transparent, I am going to ignore it, you don't even see me, I'm invisible. Now you can add and delete and do everything else on this switch. However, it will not replicate out and it will not receive replication from anything else. This is a great one to use for lab environments where if you accidentally take that switch out of the lab and plug it into the network, since it's transparent, it won't have any effect at all on the rest of your network. With that conceptual review under our belt, let's get into the configuration of the Catalyst 3550. For this nugget, you can see the topology that I've set up. I have two Catalyst 3550s trunked together. I have Fast Ethernet 0/20 through 2 through 24. And I have two routers dangling off both of these switches. Fairly simple topology, but it will let us demonstrate just about everything that we need to during this section. Now, the first thing I want to go through is configuring the base management of a switch, because this switch is brand new, out of the box. It has no configuration, and I want to walk you through the best practices that Cisco recommends when setting your switch up. The first thing that I always do on any Cisco device is I get into my line console 0 and type in logging synchronous and no exec timeout. Logging synchronous keeps console messages from interrupting my typing. No exec timeout I use in lab environments because it keeps my session from timing out and I have to keep relogging in. I'll also type in, it's a global config command, but I'll type it from here, no IP domain lookup. That, if I make a mistype, which I'm sure I will keep it from trying to query DNS and eventually time out, because it takes about a minute and a half to time out, and I don't want to sit there and stare at the screen. So there's one other command that I always type in, and it's an alias command, but I use it all the time. I'll do s equals show IP interface brief. That's one that I'll be using to show my interfaces. And let's give this switch a name. This one is switch B in my topology. I've already configured switch A to save us some time as we start into this configuration. It's just a mirrored configuration of what I'm doing here. And let's use that alias. Let's do a show IP interface brief and see what interfaces this has. Now there's all my switch ports, Fast Ethernet 0/1 through 24. This is 24 port switch. And you see right there is my VLAN 1 interface. Cisco recommends that you never use VLAN 1 for client traffic. And every security expert in the world recommends that you never use VLAN 1 for your management interface as well, because it's a huge security hole. Every managed switch, when you pull it out of the box, is configured with VLAN 1. I don't care if it's a 3-com switch, if it's a Cisco switch, whatever, it's all VLAN 1. And if you connect into your network and you're using VLAN 1, poof, they're instantly on the VLAN. That's just one of the many security hazards that you run into. So the first thing I'm going to do is I'm going to create an interface. And you can use whatever interface you'd like to, or whatever VLAN you want to, for your management. Personally, I use 128. That's just an easy to remember number for me that I always use for my management interface. And you can see right there it changed to up. Let's give it an IP address. We'll say it's 192.168.200.2. And the reason I do that is because switch A is 200.1. Now, if this were a mirror switch, I would exit out and I would type in IP default gateway and give it a default gateway that it can use to get off this network so I can do management remotely. But my friends, this is not a mere switch. This switch is a router as well. And I'm going to leave this off, which would normally be detrimental to my ability to manage this switch remotely. But when we get into the advanced configuration, I'm going to set this up with routing protocols so it can get a view of the complete network. Let's set up my security. I'm going to create a username. I'm going to say username Jeremy, password Nugget, which I'll be using all throughout the rest of these videos. And I'll also type in service password encryption to make sure that that is not stored in clear text in my running and startup config. Now, just as a review, service password encryption encrypts with, I call it a Captain Crunch decoder ring encryption. You can decode it very easily using some of the online utilities. However, it's better than nothing. It's better than just having this displayed in clear text. One thing that won't be Captain Crunch decoded is the enable secret password, which I use to get into privilege mode. So I'll type in that as well. Now let's go into line console 0 and type in login local. And I'll do the same thing for line VTY, my telnet ports. There's 15 of them on this switch, 1 through 15, and I'll type in login local there as well. What that will do is it will refer to the local database on this switch, which contains this user account, whenever somebody tries to access it, either through the console port or through the telnet ports. Now let me give you the tip of the day. I use this all the time in lab environments, and I must confess, even sometimes in full production. On my VTY and console port, I'll type in privilege level 15. What that does is as soon as I log in using that local database, or maybe I'd be using a TACAC server or a Radius server, as soon as I log in, if I authenticate successfully with whatever user database I'm querying, it immediately puts me to privilege level 15. What that is full privilege mode access. It's just as if I typed in enable secret. Because the way I look at it is if someone has the username and password to authenticate successfully to VTY or console, that's good enough for me in most circumstances, in low to medium security environments. But in high security environments, I will not include this, and I must have the enable secret as well. This way, as soon as I log into the telnet or the console port, I'll instantly have privilege mode access. And that's how we configure the management functionality of these switches. Let's get into the VLANs and the VLAN trunking protocol. I'm going to do a show VLAN just to see what VLANs are on this switch. And as expected, I see my VLAN 1, which contains all my ports. That's the default VLAN. And VLAN 128, which was dynamically created for the management interface VLAN 128 that I created. The rest of these are pretty much just to make the switch standard compliant, but you can't really use them. FIDI, token ring, FIDI net, all token ring net, and nobody really uses those. So let's start creating some VLANs. There's two ways that this switch supports the creation of the VLANs, and I'm excited that it does support both ways because some of the switches that you use may only support one of the two ways. I'm going to show you both. The first way is a mode that Cisco came out with about 2 or 3 years ago, and I really like it. It's the VLAN database mode. It gives VLANs their own sub-configuration mode from privilege mode. And in here we can create VLANs, modify our VLAN trunking protocol, reset certain changes, and when we exit out of this mode, it applies everything to our switch, so nothing applies until we exit out. I have some 2900 series switches sitting over here in the corner that only support this mode of configuration, but look at this. Warning. It is recommended to configure VLAN from config mode as VLAN database mode is being depreciated. I've never heard it referred to as that, but it must be a politically correct way of saying it's going away. So unfortunately, I really like that mode, but now everything must be done from global config mode. And this is probably where most of you are used to configuring VLANs from. We just type in VLAN followed by the number of the VLAN that we'd like to create. I'd like to create a few of them. I'll say VLAN 50. And right here it puts us in that VLAN sub-configuration mode, which is my guess that's why they're getting rid of VLAN database. And this is where we specify all of our settings for that VLAN. I can go ahead and I can set a name for that VLAN, the maximum transmission unit. Let's set a name. I'll say this is client group 1. Let's create another VLAN. We'll do VLAN 100. And I'll say that one is client group 2. VLAN 150, we'll do server group 1. And finally, I'll finish off with VLAN 200, server group 2. All right. So I'm going to do a show VLAN, and we should see those VLANs now showing up in our list, and sure enough, we do. So 50 through 200 we've created. Now let's focus in on the VLAN trunking protocol. And even before we get to VTP, we need to configure our trunks between switch A and switch B. So let's get in there and do that. I'm going to go into interface. Well, which one do we go in? 22 or 23? Well, let's go into them all. This is a cool command supported on the 3550. It's called interface range. Save you a bunch of time instead of having to type each of these commands under each interface. The only difficulty with it is that it's finicky. Watch this. I'm going to type in interface range fast Ethernet, and now I type in my module number followed by, and this is where it's kind of finicky, the port range. And here's exactly how you have to type it. Starting port, space, dash, space, ending port. And then if you want to go from there, you can actually do even a comma, and you could say, and I also want to do gigabit Ethernet and so on. You can extend it, but the spacing has to be exactly correct. If you don't put the spaces there, it won't work. So when I hit enter, I'm now in the interface range configuration mode, and all the commands I type apply to all three interfaces. And the first thing I want to do is I want to change this into a trunk, and it's going to give me an error. I want you to see it. Switch port mode trunk. The reason why is you have to set the trunk encapsulation before you turn on trunking mode. I think it's kind